If your game isn't running at over 100 FPS, you need to learn how to use this tool to help optimize your game. Hey, Chris here from LlamAcademy, here to help you. Who? Me? Yes, you! Make your game dev dream become a reality by helping you identify hotspots in your game of bad performance. Many indies, especially early on, have never even heard of the profiler. So today we're going to take a look at what this tool is and how you can use it to optimize your game. To open this up, you'll just go to Window, Analysis, Profiler, and that'll open up this window. If it doesn't exactly look like that, that's all right. We're going to talk about what all is going on here. Up here at the top left, we got the profiler modules. You're going to want to make sure that you have the CPU usage selected because that's the primary thing that we usually want to optimize. At least that's usually the biggest impact thing that we can immediately do to make it better. Then you're going to want to make sure you have play mode selected because we're going to profile in the editor right now. You can profile a development build of your game, and that'll give you much more accurate results. However, since we're talking about just identifying hotspots, this is a great place to start doing it right here in the editor, and it's much faster. Next, you're going to want to make sure that this record profiling information red button is enabled. Then if we click play and wait for a 30-second domain reload, I'm going to pause so we can capture that first set of frames. The first few frames are pretty slow all of the time. All the game objects in the scene have to have awake, start, and on enable called, and the first frame update. Unity is also initializing all of its systems. So we can do some stuff to optimize this, but we even see this in AAA games. It's not that big of a deal unless it's horrendously slow. So we're gonna skip over this part, and we can see that it's slow because it's a very tall graph here. We see a stacked graph indicating how long things take, and it's color coded by the different type of activity being done. We can see over here, rendering is this green, animation's that light blue, scripts and animation kind of look the same. And then there's this big others thing. If we click and drag in this graph, we can inspect different frames. So we can inspect exactly what happened on each one of these frames. And on the very first few frames, and even going forward, we see editor loop is taking up a ton of time. That's why when I'm profiling in the editor, I disable others because that lets us focus on our game and not be distracted by the editor loop. There are other things that happen in others, and we can see those on their own if we profile a development build. That's usually not the biggest problem area, so we're not going to worry about it in this video. Let's let the game run for a little bit just to see it even out. Let all the initialization stuff happen so we can identify where our code is causing a problem. If we let that run and then just pan through it, we can see, okay, this is actually running pretty stably. We're staying around the 200-ish FPS mark, which is pretty good. Down below the graph, we see basically like our hierarchy, these expand collapse for the different effectively function calls. These aren't technically function calls, but we can just think about them like that for simplicity. And if you don't see it in this view, you may be seeing the timeline view, which looks like this, and works more or less the same. But I find typically if we're trying to identify something, the hierarchy is a little bit easier. So I'm going to swap back to the hierarchy and let's just see what's going on in this frame. We've got player loop, render pipeline manager, do render loop. So great, this is our main camera rendering stuff, and that's taking up the vast majority of our frame time here. Looks like around 70% of the total player loop is being taken up by this. If we just drill into that, we can see, okay, we're gonna eventually render a camera stack. So we've got rendering some single camera, the main camera. Okay, that makes sense. Our main camera is gonna take up the most time. And we can see while we're selecting that the graph changes colors a little bit to highlight the stuff that we have selected. So we can see it's taking up a lot of script time and then some rendering time as well. This scriptable render context submit is taking up a lot of the rendering time from the CPU usage, which has stuff like rendering the shadows, executing our high fidelity render, this kind of internal stuff. We can't do too much about this except optimize our configuration of URP. We're not going to get into all of that, but if we do things like disable post-processing, make sure we're not doing things like multi-sampling, anti-aliasing, and have reasonable settings for our project, that'll give us a relatively good number here. Other things going on in this are, okay, we've got physics, that's taking up a relatively small amount of time, 0.45 milliseconds. We've got our AI, because these chickens are doing AI stuff. This is where our navigation, NavMesh agent stuff is mostly under. Anyway, most of the stuff isn't taking up any time, so let's click play on extreme difficulty. Okay, let's pause before we go any further. We see a spike. So this is what we're looking for. We're looking for something out of the ordinary to identify what's going on here. because we were getting really good FPS. So if we select this big spike, what do we see? Okay, this update script run delayed dynamic frame rate. What this is our coroutines, coroutine delayed calls. Perfect. So anything that's running in a coroutine is going to show up under this heading. If we expand the coroutine delayed calls, we can see, okay, this is my code. The attacker brain start takes up a lot of time here. 25 milliseconds is pretty bad for a single frame. So let's see what's going on in there. Okay, attacker brain spawns snakes. That's taking up most of that time. Oh, and it's instantiating objects. Instantiating objects is extremely slow, especially as we get to more and more complex objects with more mono behaviors, more built-in Unity components. There's more stuff that has to be done in a single frame to instantiate that object. This is why you'll hear a lot of the time, object pool everything. Even I say this, you should object pool basically anything that's going to be instantiated at runtime because of this exact reason. And if you don't know anything about object pooling, I've got a video covering the Unity object pooling system, the native system for object pooling. I'll have a link in the description and a card on the screen too, so you can implement that and get rid of this type of problem in your own game. All right, so we know attacker brain, we can solve that by object pooling. The next one, chicken spawner. This is also taking up quite a bit of time. Let's see what's going on in there. We just expand this. Oh, look, it's instantiating objects. So again, this can be largely mitigated by using object pooling where we don't have to instantiate new objects at runtime. That's really our main problem. So let's go ahead and resume and just see if anything else sticks out on the profiler. Oh, when I click on this UI to spawn a llama and then place them, we see a spike. Can you guess what's happening here? Well, let's take a look. We've got player loop, update script, run behavior update, behavior update. This is where all of the things that happen in your update function are grouped under. So here we see player building controller, update. That's taking up 55 milliseconds. That's horrible. Oh, look, we instantiated an object. If we move this little white bar, the instantiate itself took us below 100 FPS. And then there's all the normal stuff happening on top of that as well, which just tanked our FPS. Looks like we hit 30 frames per second for that frame because of this instantiate. Not good. Let's resume and see what else is happening. Okay, I spawned another one and we get a little spike there, not as bad. Looks like we're staying above 120 FPS most of the time, but we got some weird spikes right there. What happened there? So we're seeing a pattern, right? We're just playing the game, doing the stuff. We wait till we see a big spike on the graph and we pause and take a look at what happened there. You don't have to click pause either. If you click down here in the CPU frame usage, it'll pause the game for you. So what happened here? GFX wait for present on GFX thread. I'm really happy this happened because this is a really confusing one. Semaphore wait for signal. What's happening here, which also is our next spike over here, is the video card was busy. We were trying to tell it to render something and we had to wait for it to complete what it was doing to execute whatever Unity just asked it to do or whatever happened on this frame. We're going to see the exact same thing here. GFX wait for present on GFX thread, semaphore wait for signal. This tends to mean that you're GPU bound. But since we saw spikes of this, something else was happening on my PC that was blocking the video card, maybe because I'm recording and I've got this filter going on. Unclear. There's not a lot we can do about this one because our rendering time is already pretty reasonable. But if you see this GFX wait for present on GFX thread, that means we're waiting for the video card to do something. It could be that you have too much work going on your video card because you're running some complex shaders or something of that nature. If you get a random spike like this, we might find out that that's just something that happened on the computer and there's nothing you can do about it. It wasn't really your game. All right, let's continue. I might just fast forward through some of this. So I'm trying to get to that our frame rate starts going down. Okay, I think this is a good place to come back in. We can see now in our CPU usage that we're right at 100 FPS. We have a ton of units we can see from this mini map, and we've now dropped more or less around 100 FPS, let's say. We can see a lot more time is happening from physics. So that indicates from what we saw before that there's a lot more physics activity going on. So if we come to player loop physics update, we can see, okay, yeah, it's still only taking about 1 millisecond, but how we have our game structured means that as our units scale up, our physics time is also going to scale up. And we can work out, does that scale proportionally or what exactly is going on? We can also see that our update script behavior update is taking up more time. Here we can see 78 calls to unit base update. So we've got about 78 units that are not llamas and not chickens are currently alive. That's between the snakes and the foxes. And this is taking up more and more time, which makes sense. Unity calling update on every mono behavior ends up getting very slow. And if you haven't watched the whole chicken defense series where I covered exactly how to make this game, the full project's on GitHub, you can run this exact same scenario. If you haven't watched that, What is happening in unit base is we have a finite state machine that is updating every frame. So unit base is updating the finite state machine, which is pretty fast, but we can tell that as we get more units, if we're talking about maybe capping it at around 100 units, this is no big deal. This is fine. We're still running at 100 FPS. But if we were to scale this to 500 or 1000, this is something to watch out for, because we can see that it's scaling up and getting slower, and it's dramatically slowing down our game. We're 20 FPS slower than we were a minute ago. And this is one of the most interesting aspects of using the profiler and just doing performance optimization. We want to set a performance benchmark. In this case, I'm saying 100 FPS, but whatever you need for your game. We can identify those hotspots that are breaching that threshold, and then we can come up with an action plan to remediate them. And we can also look at, okay, well, in this scenario where I only have 78 units, okay, I'm going to cap it at 100. That's not a big deal. And that's more like the second phase. In phase one, we're just identifying the hotspots, fixing those burning fires like we're calling instantiate all the time, and it's causing a negative impact to our performance. Cool, we're going to use object pooling, solve that fire. We're good. Now everything looks like it's running pretty smooth. Okay, the next thing is, well, I want to have 500 units going on in this game. This is a potential hotspot for us because we can see that it's not scaling well. We've got both unit base update. We can see that there's more and more physics time coming in. We see there's more and more animation time. All of these things we can see are scaling, I don't know, linear is the right word, but they're scaling with those number of units. So we'd like to probably run some scenarios with a maximum number of units we'd like to see and see, does that fall within the target threshold of performance that I'm looking for? So in this video, you've seen how to use the profiler, identify those CPU usage hotspots, seen how to identify where that's happening in the game, in our code, and some solutions to some common problems we see in this game. I hope this introduction to the profile was helpful for you in optimizing your game. And if it was, make sure you liked and share it out with a friend who would also get value out of this video. That helps more people get exposed to this important information, and it's totally free for you. If you want to show your support for this channel, there's a few ways you can do that. You can use the affiliate links down in the description to do your Humble Bundle and Unity Asset Store shopping. You could purchase my Shader Graph course. It gives you a great introduction to using Shader Graph and gives you a little bit of how to think in shader language. You can become a Patreon supporter or YouTube member. Both of those will get you access to a private members exclusive Discord, and you'll get your name up here on the screen at the end of every video and your name in every single GitHub repository, because all of my videos have the full free project on GitHub. Starting at the awesome tier, you'll also get a shout out like Ivan, Iphiopoulos, Jason Hansen, Snedden, Trey Briggs, Will B, Mustafa, Nick5454, and Pixel Wizards. There's also all of these great supporters as well. Thank you all for your support, and I'll see you on the next video.